I'm Craig Stewart. I'm the XSEDE Manager for Campus Bridging Activities. XSEDE is an NSF-funded project, the Extreme Science and Engineering Discovery Environment. It's a multi-year, multi-institution project to provide computing, data storage, analysis, and visualization resources for the open research community in the United States. Campus bridging is one particular theme area within XSEDE, and the idea behind campus bridging is really simple. The idea behind campus bridging is to let an individual student or a researcher or a staff member treat local cyber infrastructure, local computers, national cyber infrastructure systems as XSEDE, all as if they were just peripherals attached to the back of your laptop. Now, the idea behind campus bridging, the campus bridging name really came from the observation that if you were a researcher used to using your own campus resources and you went to use one of the national facilities, it just felt like you were falling off a cliff. The transfer of knowledge from local systems to nationally funded systems was very low. You really had to do a lot of relearning. So one of the things we're focused on in XSEDE Campus Bridging is trying to make it easier for people to transfer their skills from their local clusters to the big clusters that are in XSEDE. There's no way to have half a dozen or a dozen big supercomputers in XSEDE all be like hundreds or thousands of campus clusters set throughout the US. What we can do is provide tools that will make it easier to build campus clusters in a way that's more consistent and compatible with the XSEDE cluster. So what XSEDE is doing is releasing a set of software tools that enables a campus cluster administrator or a campus-based researcher to build a computing cluster from scratch if they wish in a way that's compatible with XSEDE and make what we call a basic XSEDE compatible cluster, or take an existing cluster that's running well and add software to it so that you have the tools available locally on your local cluster that match what you're using on XSEDE. Now there are a couple things about this that are great. First of all, the set of tools for building these clusters, it's a lot easier than building them from scratch. You know, this is 2013. We do not need to have every cluster that's built in the United States designed from scratch with a software build that's pulled out of thin air by an expert. So we've taken some of the best experts we can get in XSEDE, some of the best experts we can find from campuses, and we've created a software distribution that has a set of software tools that we think match most of the needs of most researchers throughout the US based on open source tools. And basically, with click of a button, you can build a cluster from scratch. And by downloading a set of RPMs, you can make an existing cluster have, in addition to its existing functionality, the commands and functionality and software that you find on an XSEDE cluster. So the big wins here are from the researcher standpoint. You get to use local clusters that feel like an XSEDE cluster. From the educator standpoint, if you're doing classes, how great is it to have one set of class materials that you can use for a local cluster or for XSEDE? Or better yet, if you're developing a class, how great would it be to just grab materials from XSEDE and be able to use them on your local cluster? And from the standpoint of people that are building clusters, and let's face it, most universities have IT staff that are stretched too thin. If we take a process that takes days, a week to do, if you do it by hand, and automate it, that's a big win for IT staff because the time they're not spending building a cluster, they can spend helping users. So we're basing this technology on ROCs. So if you want to build a cluster from scratch, we've got a ROCs role that you can download and install. If you've got a cluster that's already working, we've got RPMs that you can download and install as well. The whole idea is to make it as simple as possible to extend the knowledge that people have about XSEDE clusters down to the campus and make it possible to build campus clusters so that your knowledge then becomes transferable also to using XSEDE machines.
The ease of installation and management of the ROCs role makes it unbeatable. In addition, the tools on XSEDE are very useful for Howard research. That more importantly, the tools are now locally available, making the transition to XSEDE resources that much easier.
The XSEDE Compatible Cluster Kit is based on RPMs for ongoing upgrades, for adding software, for maintenance. RPMs are a very standard approach to patching a Linux cluster, adding software functionality. If you want to build a cluster from scratch, then we're using a tool called ROX, which is well known for its ability to stand up and build a cluster from scratch. It's pretty easy to use that. ROX is a great tool for starting a cluster. RPMs are great tools for maintaining clusters. So between the two approaches, we allow people to stand up and then maintain a cluster very easily. And the software that comes with the clusters includes a number of campus bridging tools that are already in wide use in XSEDE. For example, Globus Online, which is one of the most widely used tools for moving data from point A to point B, is part of the XSEDE Compatible Cluster Build Kit. So if you haven't used Globus Online already, it's a great way to move data from campus to XSEDE, from campus to some other national repository. With the XSEDE Compatible Cluster Kit, the Globus Online software comes baked in. You turn on the cluster, and it's very, very easy to use to move data around wherever you want to move it.